All right, we're still dealing with direct substitution, and this time the problems are limits that don't exist. So this is one of those cases I had said last time, reminding you that be careful when your x is in the bottom, be careful when your x is under a square root sign, and then be careful when your x is inside a logarithm. Okay, so let's go ahead and take a look at what this situation is. Notice we have an x in the bottom of our fraction here. So we would look at it as, I'm just focusing on the bottom, this bottom cannot equal 0. This bottom cannot equal 0, right? So if I add 2 and I add 2, we see that x cannot equal 2. And notice that's where the x is going to. The x is going to 2. It's going to that discontinuity or that issue. So if you just plug 2 in like we've been practicing, you have a 0 on the bottom. It's also real important to know that there's nothing we can do to cancel out this error or this discontinuity or this issue. So it does not cancel out. So that's kind of the key, is if you can cancel it, then you can keep going, you keep working and deal with it that way. But if it can't cancel, then we're kind of stuck. And notice, I just wanted to kind of show that if we go to the Desmos calculator and I went ahead and I graphed the function right here, here's our 2, and notice that as we go from the right side, as we go from the left side, does it go to the same point? Definitely not. It goes to positive infinity and negative infinity. That's another sign that the limit does not exist. Remember, it has to go to the same point. So in this case, it's good to kind of recognize these facts, that the x is in the bottom. It can't be canceled out, the issue, and it's going to different places. Does not exist. Once again, same kind of issue here, but we can plug it in and see what happens. So let's go ahead and do that. So focus on the bottom here. And you can kind of go through like I did last time, see where the problem is, but that's kind of a long way of going. I just wanted to show you that. If you have to deal with those, that's kind of the domain issue. The domain issue on the last one was when x was equal to 2. It's not an issue on this one. Let's go ahead and plug that 3 in and see what happens. Now, we have to plug it in for the whole problem, Now, the last time was because we were just looking at the bottom. This time, and it's always important, we want to do plug it in for the whole function here. So if I plug it in for the whole function, I get -4 on top. 2 times 3 is 6 minus 5. And I get -4 over 1, which is equal to -4. So no issues here. Just got to be careful. It looks like if x was 5/2, we would have issues, but it's not. It's 3. So our answer is -4. No issues on this one. But you just kind of, like I said, recognize that this is one of those issue areas, but we're not going to the issue spot, so we're okay here. Did the next one's any different? And everything looks like it's done exactly the same. Okay, so just by looking at it, we can see that if we plug the -3 in, we get a 0 on the bottom. So it does not exist. Okay, and if you wanted to, you can kind of take a look at the graph too to help you with kind of understanding it. I like clicking on it.